Hi, I am Swamigdha and I will be solving question number 2 of homework 6. Okay, so what do we have been given in question number 2? So for question number 2, we have been given the joint density function of xy, which is equals to a b, which is a constant, and x square plus y square is less than equals to 1 and 0 otherwise. What does this mean? X square plus y square is less than equals to 1. It means x and y are both inside a circle, including its boundaries. Okay, what do we need to find? We need to find b such that the joint density function of xy is a valid joint density function. We need to find the expectation of x given y equals to y, then we need to find expectation of x given y, then expectation of y, then expectation of y given x equals to x, then we need to find expectation of y given x, expectation of xy, then we need to find the correlation between x and y. So okay, for the first part, for the joint density function of xy to be a valid probability density function, the entire integral has to be 1. So if we begin with x, x goes from minus under root of 1 minus y square to plus under root of 1 minus y square in a circle, if you look at it. So we find to be b is equals to 2 by pi. Okay. Then now expectation of x is x fxy dy dx. So we do the same procedure as the above. Per x into 2 pi, which comes around 2 pi goes outside, it comes x square by 2. Now it is complementary limits, so expectation of x is equals to 0. Similarly, expectation of y is also equals to 0. And now expectation of xy is xy fx dy dx. So if we do it with respect to x, the limit goes from minus of under root 1 minus y square to plus of 1 under root 1 minus, then it again becomes what? X square y, x square x goes from minus of under root of 1 minus y square to plus of under root of 1 minus y square. So expectation of xy is also 0. Okay. Now, for the next steps, we need to find the density function of y given x, which is the joint density function divided by the density function of x, and also similarly density function of x given y, the joint density function divided by the density function of y. So fx is the density function of x is 4 by pi x under root 1 minus x square, and the density function of y similarly is 4 by pi y under 1 minus y square. So density function of y given x, the 1 over 2x under 1 minus x square. Similarly, density function of x given y, it is equal to 1 by 2y under root 1 minus y square. So expectation of capital Y given capital X is equals to small x, which is equal to y f density function of y given x dy x, y grows from minus under 1 minus x square to 1 minus x square, which is again 0. Similarly, expectation of y capital X, capital Y given capital X is 0. Capital X, expectation of capital X given small y is equals to 0. And capital expectation of x given y is also equals to 0. So everything is 0 at the end. So for the we need to find the correlation between them. So covariance can be defined as expectation of xy minus expectation of x, expectation of y. Every value is 0. So covariance is also 0. So we can say that x and y are uncorrelated.